Ladies and gentlemen, start your engines. All right, I'm kidding. Don't start your engines, but we got 2 more talks left. The penultimate talk is going to be from Jan Soubusta, who is from GoodData. He's going to be talking about scaling real-time RAG for analytics. Go ahead and give him a round of applause, please.
Hello, everybody. I didn't expect that there will be so many people here, so I'm a little bit nervous. I'm happy to be on the stage. First occurrence of Vector Day. That's great. It's not because we are paying customer of Qdrant, I assure you. What I'm going to talk about is actually my presentation is going to be a little bit different than what you have seen here so far. We are not like builders of some AI frameworks or AI like platforms. Instead, like GoodData, you can like derive it from the name. We are focused on the data, specifically on business intelligence. That's the traditional name, which is with us for decades. Now, sometimes we call it analytics. So we try to convince users that this is not true. Yeah. What I would like to tell you in the very beginning is that we, like all business intelligence vendors, have failed so far. Yeah. And why? The first reason is like how many people here actually uses Excel for like analytics, data analytics? Oh, it's better than. But you are actually not the typical audience. You are not the corporate bitches, right? So, and we try to fix it, including like my company, and we built a self-service business intelligence tools. And they are so complicated that maybe 5%, like in the large enterprises, can actually use something like Tableau or Looker or Power BI, right? So the question is like, can AI fix it? Can AI be like the ultimate solution for this mess, for this failure? And specifically because we are like here on Vector Day, so the obvious question is, are LLMs enough to solve it? And obviously the answer is no, yeah. So first of all, we need some kind of retrieval augmented generation stack or architecture or whatever. And in our case, in the case of business intelligence platform, it means that you need to vectorize analytics entities. Let's call it analytics entities. We call it semantic layer, by the way. Recently, Snowflake announced a huge like activity around standardizing semantic layer for all vendors all over the world. Good luck. What we specifically do, but I suppose that it's happening also, for instance, in Power BI or in Tableau, is that immediately after any analytical objects are changed, it's streamed near to real time to this retrieval augmented generation part of our platform, and we vectorize everything what matters, yeah? Which means like business titles, business descriptions, but also like relationships between objects, yeah? And I will be talking about it a little bit later. Specifically for that, we use a small language model which is running locally in our microservices. We benchmark these models like a lot. We also are constrained with the fact that we actually operate in the whole world, yeah, like in all regions, so we have to be multilingual. So we were looking for a small language model which is not big, not too big enough, not too big. So it's cheap, like to operate in our premise, and at the same time, it's powerful enough. So for that, yeah, there is nothing here. Okay. So for that, we used a paraphrase multilingual mini-LM model. It may change in the future, but for now, it works best for us. Okay. But that's right. That's how we create like a document store with vectors and with everything else. But then we need to do a retrieval, right? And for this purpose, we obviously use the same small language model, but it's actually not enough. Like the simple similarity search is not enough. We tested it thoroughly, actually, like with many customer models, which are very huge. Our customers are actually quite stupid, so they are like creating models with thousands of tables or logical data sets, and they are actually like very similar names, confusing names, and so on. So to make it even like more accurate, we decided to apply also some kind of re-ranking. And for that, we use a different model. Again, we somehow benchmarked it, and finally, we decided to use this specific model. Additionally, we also decided to implement something, and that was actually requested by customers, what we call deep search, which you may consider as a first naive step to something what is now called GraphRag. And in our case, we basically like go through the dependencies between objects, meaning like there is dependency between dashboard and visualization, visualization and metric, metric and fact, and so on. So if user searches for something, we can actually go through these dependencies and find even objects which are not relevant, but like their parents or like either parents are relevant. Okay, so that was about like read and write, but in our case, it's a little bit more complicated, yeah, because we are especially active in the United States, but also in other regions, and our customers are actually extremely large. Like I'm talking about customers like MasterCard, for instance. And so we need to be able to scale out as much as possible, yeah, and be as efficient as possible, so our margin is as high as possible, right? So for this purpose, because like everything what we build is actually written in Python language, and there are many actually like issues with Python when you need to scale out. Yeah. So for the purpose of concurrency, we utilize async task group, and it's like good enough. Yeah. But for the parallelization, it's a little bit more complicated because when you like create embeddings, it's actually CPU heavy or GPU heavy, and therefore like simple async is not enough. So for that case, we create a process pool executor in Python, and before we do it, we create an instance of small language model, and this process pool is sharing like a pointer to the same instance of the model. Because otherwise, if you would like to like scale out or parallelize more, you would need to copy the small language model as many times as like there are concurrent requests, right? Originally, and there is no blaming, yeah. Originally, we decided to go with fast embed from Qdrant. It looked much better than sentence transformer because you can create like much smaller Docker image from that and so on. But unfortunately, when we implemented this process pool with like one instance of small language model, we realized that it doesn't work with fast embed. So that's the only reason, and maybe it's a potential future like feature request. That's the only reason why we like deprecated fast embed and we return back to sentence transformer. And like for the scaling of services, Kubernetes, you can auto-scale what is stateless, obviously. In the case of Qdrant, which is stateful, they provide a Kubernetes operator and a hybrid cloud deployment. So we decided to start paying for the Qdrant, and it's definitely worth. So this is the architecture, just like you can orient in what I just was talking about for over 5 minutes. There are yeah, the picture looks differently, interesting. It was redesigned like during night by our design team. So I am a little bit surprised. Okay, so but like that is the same meaning still, yeah. So there are many changes happening in the analytical objects. All the changes are sent. In our case, we use Apache Pulsar as a messaging platform, and then Python microservices, which can scale out, are processing these requests from Pulsar, and they are creating embeddings near to real time. So users can see like all the changes almost instantly in any AI interface in GoodData. Okay. What time? Perfect. Okay. So beyond RAG, I already mentioned that RAG is not enough. So first of all, and there were quite interesting talks here today about this topic, observability. Yeah, it's absolutely necessary when you need to have something in production for such important customers. Yeah. We evaluated like many options, and finally we decided to go with Langfuse. But after this conference, I am not sure if we stay with Langfuse, but maybe yes, we will see. But it's great, and not only for monitoring and for observability, but also for testing. Yeah. So we define datasets, testing datasets with questions and expected answers. We define it like on top of our internal models we use for testing, but we realized and were quite surprised that actually there are customers who are willing to share their environments with us for the purpose of LLM testing. So we are also testing on top of real customer solutions, which is like very good. Nothing is happening. Now, here is the testing pyramid we use. We started with LLM as a judge, meaning we tested everything with LLM, like everything. Yeah. And we quickly realized that not only it's expensive, but also it's actually very slow. Yeah. So one of my colleagues who is somewhere here, he implemented this testing pyramid, and he utilized for this Langfuse as much as possible. Yeah, so we first like apply some analytical metrics. Then, if necessary, we apply deterministic assertions. And only then, if it's still necessary, LLM is called, and it basically finally evaluates if like the quality is high enough. Another use case, and also Langfuse helped here significantly, is benchmarking LLMs. Yeah. In the very beginning, we decided to go with OpenAI. We are paying customers of OpenAI. And like back then, the only like good enough model was GPT-4o. I'm talking about like 1 year ago, right? So the situation is completely different now, right? So that's why we implemented like a tooling for such a benchmarking, and here you can see the results. These results are actually not fair, meaning our prompts are optimized for GPT-4o, and that's why GPT-4o is so good here. Yeah. On the other hand, you can compare anything else between, like, yeah. So what you can see here, for example, is that GPT-5 is not only extremely expensive, but also quite stupid, yeah, which is quite surprising. On the other hand, Google models are extremely good and at the same time extremely cheap. So that's quite interesting, and we are going to like think about to migrate out of OpenAI to Google as a default LLM provider in GoodData. Okay, and the ultimate goal is something like GraphRag. Yeah? I suppose like people from Cogni were presenting here, we are in touch with them and we tested their product. There are other options on the market as well. being able to define analytics as a graph is extremely important, because the logic behind complex analytics, when you have a very complex model and very complex relationships between data sets, in this case, it's actually very complicated to identify what can be calculated, what provides correct business values, and what does not. Yeah. And in that case, if LLM would have the graph where even like the connections have some like properties, in that case, we could explain LLM the whole complexity of what can be calculated and what not. And then the accuracy should be almost 100%. That's what we would like to do, like maybe this year, maybe in the beginning of next year, we will see. And this is how it could look like. This is like a particular knowledge graph built from some kind of ontology from a real customer solution. Okay, demo. How much time do I have? Perfect. Okay. First, I wanted to show it live, but 2 days ago in Prague, I completely, like, miserably failed, so I decided to use screenshots instead. But this is from real production environment. Yeah, just few screenshots. What we provide now to all our customers, what is generally available in all regions. There are no agents, just an interface for real business users. Yeah. So they can search, obviously. Qdrant is under the hood. They can find something relevant, but they can also realize that there is nothing relevant. And then they can click to ask AI assistant. And AI assistant auto-generates a question and returns some data-related answer in the form of visualization. They can also ask for something what is actually not possible to calculate, and we are trying to explain it, why it cannot be calculated. Yeah, okay, sorry, that was a wrong, wrong description. So this is an onboarding experience that's actually very important, because the business user doesn't know anything about GoodData in the very beginning. So even if you ask completely nonsense question, you get some guidance what you can do. When you ask about the environment, you actually get an answer related to the environment, what you can exactly do there. When you ask an unrelated question, that was the description I made, you get a reasonable answer. There is also auto, how it is called, IntelliSense. So users can actually search the objects and they can confirm them, and then there is no LLM in the game. That's important, yeah. When you need to be absolutely sure, you can search it before and guide LLM exactly what the object is. And you can like follow up in the conversation. Yeah, so when you create something, you can then extend it and replace it and whatever. The whole conversation history is taken into account. And this is the observability. As you can see here, one request to GoodData is actually like one step. But first we do some kind of intent recognition. Then we somehow normalize the question. We extract the keywords, which are actually an object in the semantic layer. And only then we call LLM. And we ask LLM to build a visualization definition, for example. And last but not least, no one here, I'm quite surprised, no one here mentioned this. And I think it should be emphasized again and again and again. In this world, in the world when everything is accelerated by AI, there is nothing more important than speed. If you are not fast enough, you basically lose. Yeah. And to make your people fast enough, they need to train their language skills so they can, because it's no longer important to write the best source code like in the world. It's much more important to be able to describe what I want, the design, the architecture, these things, yeah. And developers are not ready for that, at least not in GoodData, right? Yeah. So they are pushing back, I am pushing back, and to help them, I am building various artifacts to help them, like Qdrant files, our own MCP servers on top of our private repositories, and many other artifacts. And that's all from my side. Thank you for listening and for attending.